Alright, good day students. In our last class we introduced learners into proportion and we took some examples on direct proportionality. In this class we shall be looking at the other kind of variation or proportion. Like I said, it's the inverse proportion. So we'll be taking some examples on inverse proportion, and I'm sure at the end of the class you'll be able to solve any question that comes your way on inverse proportionality. Now, what is inverse proportionality? It's a relationship where as one item is going up, the other is coming down. I'll use a vivid example in this age and time. The longer you stay on the internet, what happens to your data? You see that your data keeps what? Reducing. That is inverse proportionality. The length of time you spend on social media, on the internet, browsing different pages, what happens to your data? Your data will be reducing. That is inverse proportionality. How do we represent inverse proportionality? Follow me on the board, please. Inverse proportion. In inverse proportionality, where I have two variables, let's say y, is inversely proportional. Because of that word inverse, it's 1 all over. Inversely proportional towards x. I use the example saying y is length of time on internet, while x is my data quantity. So the length of time I spent on internet is inversely proportional towards my data quantity. So the longer I spend on the internet, the lesser my data quantity. Alright, now I told you when we were introducing variation, we said what? That you need to remove this proportionality sign. And to remove the proportionality sign, what happens? You introduce your equality sign. So I'll be having my y to be equal to, I introduce a constant k multiplied by my 1 over x. So this can be written as y equal to what? K over x. You make k subject of formula, you'll be having my k to be equal to cross multiply. That's the same thing as cross multiplying yx. Alright, now this is the general formula for inverse proportionality for this equation. Now we've gotten this. Now let's see how to apply it in examples. Example 1. If y varies inversely as the square of x, find the relationship between y and x if y is equal to 8 and x is equal to 2. Alright, now we are given this question. This is how a typical question will come. We'll still add other additions to that question, but let's see how to solve this. Now, solution. The question says what? If y varies inversely, y, your variation sign, varies. When you hear inversely, what do you do? 1 all over. Varies inversely as the square of x squared. I've interpreted this sentence. If y varies inversely as the square of x, y varies inversely 1 over the square of x. They say we should find the relationship between y and x, and if y is equal to 8 and x is 2. So let's take away our variation sign. I'll be having y equal to k multiply by what? 1 over x squared. So I'll be having my y to be equal to k over what? X squared. Now I need to look for the value of k. How do I do that? This is the same as over 1. Cross multiply. Cross multiply. That's 1 times k is what? K to be equal to yx squared. So I'll be getting my value of k. Anywhere I see y, what's the value of y? They said anywhere I see y, I should put what? 8. Y is equal to 8 times. Anywhere I see x, I should put what? 2. 2 squared. So this is the same thing as writing 8 times 2 squared means 2 times 2, which is what? 4. So I'll be having my k to be equal to 32. So now I've gotten my constant, which is what? 32. I'll now introduce it into our equation here to get the relationship. So my relationship will now be y is equal to, anywhere I see k, because it's a constant, I'll put what? 32 all over what? X squared. X squared. This is the relationship that they're asking you to get. Y equal to 32 over x squared. Now that's the relationship. Alright, quickly we'll be looking at other examples and going into details with inverse variation or inverse proportionality. Alright, example 2 says what? The volume of water which a hollow pipe can pump from a well to a tank varies inversely as the distance between the well and the tank. With a distance of 1.5 meter, the volume of water pumped is 40 meter cube. The first question says find the law connecting the volume and distance. The second question says find the volume if distance is 20 meter. And the C part of the question says find distance if volume is 80 meter cube. Alright, let's quickly dive into our solution. So you always start your questions with solution. Alright, now solution. Let's come to the question. They say the volume. Let's represent volume by V. Volume V. The volume of water which a hollow pipe can pump. Leave all these stories. Just read them, but don't put much interest in this. The volume of water which a hollow pipe can pump from a well to a tank. This is where you continue. Varies inversely. Varies your variation sign. And because of this word inversely, what do? 1 all over. Varies inversely as the distance. Let's represent distance as what? D. As the distance D. Between the well and the tank. Alright, now we've gotten this as our interpretation of the question. Don't forget we are solving the A part. Now what do I do? To take away variation sign, what do? You introduce what? Equality. So I'll be writing this as V equal to, because I remove this and put equality, I'll be introducing a constant. I say mostly we use the constant as what? K. So I'll be writing K over what? D. Now this is the relationship they're asking us for. But don't forget that K is a constant. You need to get the value of that constant to write your relationship properly. Now the question gives us values so that we can get that K. They said with a distance of 1.5 meter, anywhere I see D, I'll put what? 1.5 meter. The volume of water pumped is 40, so V is 40. 40 equal to K over 1.5. So cross multiply, I'll be having my K to be equal to 40 times 1.5. 1.5 is the same as 3 over 2. So if you divide 20 times 3, you'll be having 60. So my K, which is a constant, is what? 60. Alright, I've gotten my value of K as 60. I'll now introduce this K as 60 into this relationship. So my first question now, my V will be equal to, anywhere I see K, I'll be putting 60. 60 all over what? The value of D. This is the relationship that the A part is asking you of. You can see that in my relationship, I still left my variables in what I chose, V and D. It's just the constant, I put the value there because this equation guides us in solving the other questions. Now the B part of the questions. The B part of the question says we should look for V if D is 20. our D is giving us what? 20 meter. They say we should find V. V is unknown. We don't know what V is. But we have the equation. We know that my V is equal to 60 over D. So anywhere I see D, I'll put what? 20. So my V is equal to 60 over D. I'll put what? 20. So my V, if you divide, this cancel this, 2 and 6 is what? 3. I'll be having my V as 3. But don't forget, V has a unit. In the question, they gave us V as what? Meter cube. So I'll be writing 3 meter cube. The C part of the question says what? I should look for the distance if volume is 80 meter cube. In the C part, they gave us V as 80 meter cube and asked us to find D. We don't know what D is, but we know the relationship, which is this. You always write your relationship 60 over D. So anywhere I see V, I put what? 80. 80 equal to 60 over what? D is unknown. We are looking for D. Cross multiply. Just take D here, bring your 80 here. So I'll be having my D to be equal to 60 over 80. If I divide, 2 here is 3, 2 here is 4. So I'm having 3 over 4. So my D is equal to, you can write in fraction or you convert to decimal. I prefer converting to decimal. It is better. If you convert to decimal, it's 0. 4 in 30 is 728, 5. So my D is 0.75. What's the unit for D? Meter. Meter. Alright, we've succeeded in solving 2 questions. Alright, now I'll be giving you some examples, some takeaway questions that you try on your own. Try to solve them. If you're having any challenge, you on the comment section of this video, you put it there. Don't forget to subscribe to the channel so that anytime a video drops, you'll be the first to be informed of it and you go there and watch. I celebrate you. The next thing you see on the board are the questions that you are going to practice at home. Thank you. Alright, the practice questions. Question 1 says, the electrical resistance of a wire varies inversely as the square of the radius. If the resistance is 0.24 ohm, this is the symbol for ohm, where radius is 0.5 cm, centimeter, find the resistance when radius is 0.04 centimeter. That's the first question. The second question says the intensity, symbolized as I, of illumination given by a projector varies inversely as the square of distance d of its lamp from the screen. If the projector is 20 meters from the screen when intensity is 2.5, find the distance from the screen when intensity is 62.5. Just 2 practice questions. Try your hands on those questions and let's see how well you've understood this topic. I thank you for listening to me while I taught on inverse variation. In our next class, we shall be looking at joint variation. That is the combination of inverse variation and direct variation. Don't forget to hit on the subscribe button and also the notification button so that when any video drop, you will be the first to see it. I celebrate you.